Hello, my name is Naveen Raju. This is Jarrett Taylor, Joshua Gu, and Shazeb Khan. We're the Super Engineer Bros, and our project is the Reactive Insulin Pump, or as we like to call it, the artificial pancreas. The aim of our project was to address issues with the insulin therapy industry for type 1 diabetics. Specifically, we set out to create an accurate dosing system to combat traditional means that have proven to be very inaccurate and to hopefully alleviate the pressures of skyrocketing insulin prices across the industry. Industry attempts to address this issue have been extremely expensive and ridiculously selective.
So our project, we're using a closed loop system, and our closed loop system is comprised of an externally worn insulin pump on the body, a CGM, which is a constant glucose monitor. The constant glucose monitor measures biometrics such as just blood glucose levels. That data is sent to our microcontroller, which is then sent to our monitoring device. Monitoring device will update the patient on when insulin was injected into their body, what their blood glucose levels are, and how often their injections are, and if their insulin levels are too low or too high. Then the microcontroller will have an algorithm for that will be read from the CGM. There's going to be a level of 210 mg per dl, which is your insulin level, and that is, for an average patient, that's a high insulin level. So if it's too high, it's going to send insulin directly to the body. If it's too low, it's only going to send an update to our monitoring app saying that you have too low blood levels, and it's just going to update it.
Any questions?
Any questions?
Okay.
I've been diabetic for about 45 years, and there's so many variables that you have to deal with, body size, type of carbohydrates that you're taking, exercise, this, that, and the other. How have you taken those into consideration in designing this?
Using our monitoring app, it's going to be customizable to various different variables. We still have to do a little bit of research, but you'll be able to manually change or add different variables that will affect the algorithm that we're using in the microcontroller to update your body's insulin based on who you are. And we will also be implementing pattern recognition for the system for the microcontroller and the monitoring device to basically learn who you are, your peaks and pits, and everything like that to react more intuitively to your body.
You just found yourself a consultant now.
So if it's wearable, like, I guess two questions. I mean, what do you do when you got to take a shower? I mean, do you unhook it, or how does that work? And then what happens when it runs out of batteries?
We'll have monitors for battery and something like that. So it will send you, oh, your insulin pump is low, and you'll get a notification ASAP. You don't need to have the insulin pump on you at all times, or from what I understand, it's okay to take it off when you're taking a shower or something like that. But you can have it on when you're asleep, and it'll monitor throughout the night.
One of the challenges of this particular project for you is that one mistake and the patient goes into a coma. So how do you make sure that you get 100% error-proof injection?
For right now, we're going to be refraining from testing on anybody. So the basis of our system, like, obviously, but for the basis of it, we want to make sure that we have the algorithms working and everything like that, that we have multiple therapies taken into account so it addresses to the person. So as far as implementing it later on, that would come after we fully understand the system.
You need to consider redundancies and various different type of errors that have not been thought of, like for example taking shower and shorting out a variety of different use cases where you could have this problem. And one mistake and you're out of business.
Orange Jade. Can I ask one more question?
Yeah, one more question. So I'm not entirely clear how the communication is between the devices. Can you explain that?
The communication for the devices. So the physical insulin pumps, or the models that we have been using, or that we realized that we have approved for this system, is insulin pumps made before 2011 under those specific models and reservoir sizes have an RF receiver. So through the microcontroller, we can send a Bluetooth signals for the information that the insulin pump needs to have the specific data, like to what the amounts that it's going to be pumping into your body at a specific time. We will be using the CGM, which has Bluetooth connectivity to the microcontroller, so between there. And the phone won't be directly communicating with the CGM. It will be passing data to the microcontroller. The microcontroller will be updating it regularly.
Okay, thank you.
All right, let's thank the team.